Calculus, officially defined as the branch of mathematics that deals with the finding and properties of derivatives and integrals of functions, or put more simply, the mathematical study of change. Calculus is about a lot of things. Differential calculus deals with the derivative, or the rate of change of a function at any given point, and the opposite of that would be finding the area under a curve using the integral. Of course, for some people, calculus is less about the math and more about something like getting college credits. And for those people especially, but really any kind of person, sometimes calculus is just hard, which is understandable considering how many layers a single calculus problem can have. But then there are people like me who think of calculus as more than just a class you take in college or high school. I think that calculus is all about relationships, including those between area, volume, time, temperature, and so on. Then there are the relationships between mathematical concepts like the Pythagorean identities or the limit comparison test. Perhaps the most relevant demonstration of mathematical relationships to this video would be the Taylor series, but we'll get to those later. The point is that these relationships didn't just sit around, meditate, look for clues, and suddenly go, "Hey, wait, I discovered myself." There are people who had to devote their lives to figuring out what the relationships between these concepts and properties actually are. Now might be a good time to get out a piece of paper while I start going into the history of one of these mathematicians in particular. Right now I want to talk about Euler. Leonhard Euler was born in 1707 and died in 1783. He is arguably the greatest mathematician of the 18th century. Some would say Lagrange, but I happen to disagree. Euler published a total of 886 books and papers in his lifetime, a number that is only exceeded by Paul Erdos. In fact, Euler is credited with so many different equations and theorems that saying Euler's formula will have at least 5 different meanings depending on the context you say it in. Amazingly enough, the bulk of Euler's publications actually came from the last 2 decades of his life, in which he was totally blind. At this time, I'd ask you guys all to make sure that you have a paper and something to write with, because we're going to prove one of the identities that Euler published in his lifetime. And there you have it. e to the I pi plus 1 equals 0. We have successfully related 5 of the most significant constants in the entire world of mathematics. Of course, you could also cheat and say that e to the I pi raised to the 0th power is equal to 1, but that isn't nearly as interesting. To people like me who care about mathematics, this is math. This is why we do math, to find connections, correlations, and relationships as remarkable as this one in numbers. I have a friend who likes to joke with me, and he once said that mathematicians get paid to mess around with numbers all day. And to some extent that is true, because this probably took Euler and undoubtedly his colleagues a lot of playing to figure out. This formula is called Euler's identity, and it was first published in 1748. In addition to relating these 5 important constants, it also uses 3 basic mathematical operations once each: addition, multiplication, and exponentiation. From the time of its publication through the present day, this identity has been cited as one of the best examples of mathematical beauty. How exactly is it possible? How does an irrational number raised to the power of a complex imaginary number come to a value that, when added to the most basic integer, equals 0? To me, this equation is the Platonic example of mathematics, an endless series of problems created by people to try and make sense of the world we live in, to connect what seems isolated and arbitrary, and to make it a part of something much, much bigger.